Early life and background. Sir Isaac Newton was born on January 4, 1643, December 25, 1642, according to the Julian calendar used in England at the time, in the small village of Woolsthorpe, in Lincolnshire, England. His father, also named Isaac Newton, was a farmer who died 3 months before his son was born. His mother, Hannah Askew Newton, remarried when he was 3, leaving young Isaac in the care of his grandmother. As a child, Newton showed little interest in farming, the profession his family expected him to pursue. He was a quiet, curious, and intelligent boy who preferred reading and mechanical experiments. He constructed windmills, clocks, and even a sundial in his early years. Education. Newton began his formal education at the King's School in Grantham, where he excelled in his studies. In 1661, at the age of 18, he enrolled at Trinity College, Cambridge University. Initially, the curriculum was dominated by Aristotle's philosophy, but Newton was more interested in the new ideas of modern science, especially those of Descartes, Galileo, and Kepler. While at Cambridge, Newton immersed himself in the study of mathematics, physics, and astronomy. In 1665, the Great Plague forced the university to close temporarily, and Newton returned home to Woolsthorpe. This period, often called Newton's Annus Mirabilis, or Year of Wonders, was one of the most productive in the history of science. Scientific discoveries. Brain calculus. While in isolation from the plague 1665-1666, Newton developed the foundations of calculus, a branch of mathematics that studies change. Although the German mathematician Gottfried Wilhelm Leibniz also developed calculus independently, a bitter dispute arose between their followers over who invented it first. Today, most scholars acknowledge that both contributed significantly. Telescope optics. Newton made groundbreaking discoveries in optics. He demonstrated that white light is composed of a spectrum of colors, which could be separated using a prism and recombined into white light. This was a revolutionary idea that contradicted the prevailing belief that color was a mixture of light and darkness. He also developed the reflecting telescope, now called the Newtonian telescope, which used mirrors instead of lenses to avoid chromatic aberration, color distortion. This invention helped establish his reputation as a serious scientist. Milky Way laws of motion and universal gravitation. Perhaps Newton's most famous work lies in physics, particularly in his explanation of motion and gravity. In 1687, he published his masterpiece, the Philosophiae Naturalis Principia Mathematica, commonly called the Principia, one of the most important scientific books ever written. In the Principia, Newton formulated the 3 laws of motion. 1. Law of inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by a force. 2. F equals ma. The force acting on an object is equal to its mass times its acceleration. 3. Action-reaction. For every action, there is an equal and opposite reaction. He also introduced the law of universal gravitation, stating that every mass attracts every other mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This law explained everything from falling apples to the orbits of planets and moons. Career and public life. In 1669, at the age of 26, Newton became the Lucasian Professor of Mathematics at Cambridge. He continued his work on mathematics and physics while occasionally teaching. Despite his great achievements, Newton was a secretive and often solitary man, avoiding academic debates and controversies. In the 1690s, Newton became more involved in public service. In 1696, he was appointed Warden of the Royal Mint, and later Master of the Mint, where he successfully led the reform of England's coinage system and fought against counterfeiting. His work there earned him great respect. In 1703, he became president of the Royal Society, the most prestigious scientific institution in Britain. In 1705, Queen Anne knighted him, making him Sir Isaac Newton. Personality and beliefs. Newton was known to be a deeply religious man, though his beliefs were unorthodox by the standards of the Church of England. He studied the Bible and early Christian theology, writing extensively on topics like prophecy and the Trinity, though much of this work was unpublished during his lifetime. He was also deeply interested in alchemy, a medieval precursor to chemistry. Newton wrote thousands of pages on alchemical subjects, trying to unlock the secrets of nature and transform base metals into gold. While we now know alchemy to be unscientific, it played a key role in Newton's overall worldview. Despite his brilliance, Newton could be secretive, vindictive, and sensitive to criticism. He feuded with several prominent scientists, including Robert Hooke and Leibniz. Nevertheless, his impact on science was profound and enduring. Death and legacy. Sir Isaac Newton died on March 31, 1727, in London, at the age of 84. He was buried with great honor in Westminster Abbey, a place reserved for the most distinguished individuals in British history. Newton's work laid the foundation for classical mechanics, and his methods dominated science for over 200 years, until the rise of Einstein's theory of relativity and quantum mechanics in the 20th century. Sports medal legacy. Newtonian physics remained the cornerstone of science until the 1900s. He unified the heavens and the earth under the same laws of physics. He redefined the scientific method with his focus on observation, experimentation, and mathematics. He was one of the first to show that the universe operates according to natural laws, not purely theological ones. His works influenced astronomy, engineering, mathematics, economics, and even philosophy. As Albert Einstein once said, Newton was the greatest genius who ever lived, nature to him was an open book. Receipt conclusion. Sir Isaac Newton was more than just a scientist, he was a revolutionary thinker who changed the way humans understand the universe. From his laws of motion and gravity to his invention of calculus and optical studies, Newton reshaped our view of the natural world. His blend of logic, mathematics, and curiosity made him one of the most influential people in history. His legacy lives on in every satellite that orbits the Earth, every physics class taught around the world, and every equation that describes how our universe works.